Hello, and welcome to episode 99 of Daryl Show Your Work. So in this episode, I'll be showing how to encode Windows based and Linux based payloads within the MSF Venom tool. All right. So before I do that, since we are doing offensive security here and some red teaming, I'm going to give the usual disclaimer and that this is for educational research and ethical purposes only. Any sort of malicious actions that may directly or indirectly come from someone watching these videos, I do not take responsibility for it, nor do I condone. All right. So the reason that it's great to encode payloads when making them inside the MSF Venom tool is that it's going to help to evade detection by antivirus systems. All right, and then to give a high level overview of what encoding actually is, it's an obfuscation technique of modifying the payload shell code with the objective of modifying the payload signature. All right. So ultimately, our goal here is to evade any sort of antivirus systems. Though I'm not going to go that deep into that in this video, I'm just going to show us how we can use an encoder how we can apply an encoder to a payload that we create with MSF Venom. All right. So with no further ado, let's get started. All right. So the first thing that I'm going to do is I want to find what my IP address is because I'm going to need that when using the MS Venom tool. All right, so it looks like we're in an Ethernet 1 interface. All right, and then so my IP address is right here. So I'm 10.10.48.7. All right, let's copy that to mousepad. All right. All right, the next thing I'm going to do is let's dive into and looking at some different encoder types that we could use when considering encoding our payload. So I'm gonna say MSF Venom, and I'm gonna say dash dash list encoders, and this is going to give me a list of a variety of different encoders. Okay, so we can see here a different sort of encoders, and what this middle category is telling us is that it's giving us the rating of um, of these encoder types. So we want to go for evidently, obviously we want to go for something excellent. All right, so let's choose the 32-bit Shikata GNU encoder. All right, so in order to apply that to a payload, I'm going to create a payload, and within the same line, I'm going to specify the encoder type that I want to use. So I'm going to say MSF Venom. All right, then I'm going to say dash lowercase p, and this is where I'm going to specify the location of the payload um, that I want to use and to customize. All right, and that's we're going to use the reverse TCP shell. All right, and then so I have to give it my LHOST, which is going to be my IP address. So let's just paste that in here. All right, then I have to specify the LPORT, which I'm gonna just say 1234. All right, and now I'm gonna say dash E, and this is where I'm gonna specify the actual encoder type that I'm gonna use. So I'm gonna say shikata ganai. All right. Then we want to put it in an exe format, an executable format. So I'm gonna say dash lowercase f exe. All right. Now I'm gonna tell it. Let's name this encoded w x86. All right. So this is going to be a Windows based um, payload. All right, move that over here a little bit. All right. So again, explaining what I did. So I told msvenom to use the reverse TCP payload. All right. With my IP address and at the 123 listening port, and encode it with shikata ganai. All right. Excuse me, and output that to a 32-bit based a Windows based exe file. All right, so I'm gonna hit enter. Oh, let me see. I didn't like that. I forgot the S on Windows. All right, so let's go back here and add that S. Okay, there we go. All right, looks like it worked that time. So I'm gonna do a list command, just look into my local directory. All right, and there is our 32-bit Windows based payload. All right, and so then the next thing that I want to do is I want to show um, how to use something called iterations. And what iterations are, it's going to apply multiple iterations of the encoder of choice. So typically you can apply up to 10 iterations of the encoder, and the higher the iteration, of course, the more evasive your payload is going to be. But anything above 10 iterations, it's not really going to have the impact on the other payload. So I want to show how that works. So I'm going to remove um, the payload we just made, and we're going to work with a new one here. Okay. All right. So in order to apply um, an iteration, all right. So let's see. Um, I'm going to leave everything else here the same, except after, let's see, after I'm going to say dash I and then 10. All right, so that's how we specify the number of iterations that we want of the actual encoder, which in this case is a shikata ganai. We want to apply that 10 times to our outputted file here. And oops, let me see, and we should be good to go. Just move this out the way. All right. And it should show the actual encoder iterating it. Yeah, see. All right, so it starts from 0 and goes to 9. So this is 10 iterations. So it shows it iterating the Shikata Ganai encoder 10 times for us. All right, and just let me check my local directory, make sure that file is back. It is. All right. So so that's doing that with a Windows-based payload. So let's try a Linux-based payload this time. It's going to be relatively the same. All right. So just going back in my history here. All right. So of course I'm going to have to pull this from a different directory since we're not dealing with anything Windows-based. So this time I'm going to do another 32 bit based payload, but this time with Linux. So I'm going to say Linux. I'm going to say x86, and that's what you put, but you want to specify 32 bit. Say meterpreter. Then same type of attack, reverse TCP. All right, and then everything else should stay the same, except you know what? Let's do this in a different format here. I'm gonna use an ELF format. All right, and then then I'm gonna change that, get rid of the exe, and then since it's an ELF file, and then yeah, just replace this. It's L with X, so that way, all right. So again, so basically, I'm telling MSF Venom to run this 32-bit Linux based payload or the reverse TCP, and we're going to have myself as the listening host and port 1234 as the listening port. We want to use the shikata ganai encoder. We want to do 10 iterations of that, and the file format that we're going to put this in is an ELF format, and we're going to name it encoded LX 87, so we know that it is the Linux 32 bit based payload. All right, so I'm gonna hit enter. All right, looks like that worked fine. I'm gonna do ls to make sure. All right, so we have both of those files in my local directory. All right, so that brings me to the end of the video. Again, I'm not gonna go through the whole thing of trying to test out an antivirus as far as testing its evasiveness. It's outside the scope of what I wanted to show, but just wanted to show how we can once we create how when we do create our custom payloads within MSF Venom, how we can then encode those payloads to add a layer of obfuscation in order to evade antivirus systems. All right, and then how we can then apply that multiple times to the payload to further increase the evasiveness of the payload, and how we could do that using either Windows payloads or Linux payloads. So please like, subscribe, and share. Most importantly, show your work. And until next time, take care of yourself and God bless.